Hi everyone, welcome to this lecture. So in this lecture, we are going to learn about very important function which is called as softmax function. So these are the properties of a softmax function. So cross entropy loss uses softmax as an activation function. So basically softmax function is an activation function and it is used with cross entropy loss. The softmax turns all the class probabilities to values that sum up to 1. Now we know that the cross entropy loss depends upon the probabilities which are given by the model or which are predicted by the model. So what softmax does with that probability, that it transforms those probabilities to such values that can sum up to 1. It is used for multi-class classification. Multi-class classifications means if we have more than 2 classes in our data set, then it will be used with the cross entropy loss. For 2 categories, softmax equals to sigmoid. So if we have only 2 labels, if we have 2 categories in our data set, in that case, softmax is equal to the sigmoid function. So these are the 4 properties of a softmax function, that it is an activation function which is being used with cross entropy loss, and the advantage is it converts the class probabilities of a cross entropy loss into the form that we can add them to equals to 1. So here is the explanation that how softmax functions work. So this is the equation of a softmax function. We can see that here we have the exponent and here we have the sum of all the exponent. So this is our normalization term. We divide every exponent with the sum of the exponent. Let's understand the working of softmax function or this equation with the help of example. So suppose we have 3 values. This is a multi-class problem. We have 3 values. Each value is about a label. So this is a vector created with the help of cross entropy loss. So this is a vector which is created by the output layer of a neural network or a classification layer of a neural network. So we have 3 values. So basically we have 3 classes. If I add them, I will not get 1. So these are the values which are predicted by a cross entropy loss about 3 different classes. So what will happen? I will apply a softmax function in order to get the values where if I add them, I will get a 1. So the first step is to calculate the exponent of each value inside this z vector. So the exponent of minus 1.28 is 0.278. The exponent of 0.53 is 1.7. And the exponent of 0.87 is 2.38. So these are the 3 values which are the exponent of these. Okay. Now, if I adding all the exponent values, I will get 4.36. That is, if I add 0.278, if I add 1.7 and 2.38, I will get 4.36. So this 4.36 represent the denominator of this equation. This is the sum of exponent. This is the individual exponent value, that is either 0.78, 1.7 or 2.38, and this is the sum of all the exponent value, that is this is the normalization term, which is 4.36 in this particular example. Now normalize each component, that is divide the value with the normalized value. So first step is to divide 0.278 by 4.36. Then divide the second exponent with 4.36 here, and then divide 2.38 with the exponent or the sum of exponent or the normalized value. So we will get 0.06, 0.4 and 0.54. So if I add them, I will get a value equals to 1. So we can see that at the end of the output layer or at the end of the classification layer, I had these 3 values which are generated by cross entropy loss. The sum of these values were not equal to 1. In that case, I used softmax function. Softmax function transform these values into these 3 values, and if I sum these 3 values, I will get equals to 1. So this is the equation of a softmax function, and we have applied this equation on this vector. So this is the exponent of each term present in the vector, output vector, and this is the normalization term, which is the sum of all the exponent value. So in that way, we use this equation on this vector. We first find the exponent, then the sum of exponent, then we normalize each exponent. After normalization, we reach up to the values that if we add them, we will get the sum equals to 1. So in this way, we learn how softmax function is used with cross entropy loss in order to transform the cross entropy loss values into the values whose sum is equals to 1. Now, here is another explanation of the same example. We have this z vector. These are the exponent value of each z vector, and these are the normalization value. And if I add them, I will get equals to 1. So this is the result of a cross entropy loss for multi-class problem. And after applying softmax function, we will get these three values whose sum is equals to 1. So this is the advantage of softmax function, that it transforms the cross entropy loss value into the loss values, which are the true representations of the probability, that if I add them, I will get the value equals to 1. Now here is a proof that if we use softmax function for two classes, it will be equal to sigmoid function. So this is the equation of a softmax function. Now suppose we have two classes, x and y. Now for first value, here I am using ex, and this is the sum of exponent. So this is my individual value, and this is the sum of exponent. This is this equation, this value or the numerator of the equation, and this is the denominator of the equation. Okay, now the next step is subtract x from each of the exponent value. That is, subtract x from x for this term, subtract x from x for this term, and subtract x from y of this term. So it will become x minus x, it will become x minus x, and it will become y minus x. So x minus x will become 0. And here we also get 0, and here we get y minus x. So anything raised to power 0 is 1. So in the numerator, we will get 1. And in the first term of the denominator, we will also get 1. And here we have exponent raised to minus x minus y. If I take minus common here, if I take minus common, it will become x minus y. So if I replace x minus y with t, in that case, I can see that this is the equation of a sigmoid function, which we learned in the previous section of this course, that is section on activation function. So with this small mathematics, we have proved that softmax function for two classes will be equals to the sigmoid function. So in this lecture, we learn about the softmax function. We learn that it is a very important activation function, which is used with binary cross entropy loss. So we learn that softmax function transform the cross entropy loss values into the values. If we add them, it will be equals to 1. That is, softmax function transform cross entropy loss values into the true representation of the probabilities value, so that if we add them, we get the value which is equal to 1. So in this lecture, we also learn that the softmax function for two classes is equal to the sigmoid function. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.